Hey guys, today we're going to be working with radicals. I'm going to have videos on how to simplify, multiply, divide, add, and subtract. So once you're done with this one, make sure you click on the rest. Make sure you subscribe to this playlist so that you can get all of the videos on radicals and know how to do everything for this unit. Thanks for watching. The examples we're going to do today are for adding and subtracting any radical expression. The OMG we're going to be filling in works for any addition and subtraction of radical expressions. The first thing you're going to want to observe when you're adding or subtracting radical expressions is to look at what the index is. The index, again, is that small number on the outside of the radical. And then you need to look at the outside or the coefficient value, so that's the one in front, and then the inside or the radicand value. Your mission is going to be to simply perform the indicated operation, so whether it's addition or subtraction, you're just going to be going through and performing that operation. And then the game plan for doing this is 3 simple steps. The first thing you need to do is make sure your radical is in simplest form. Then you're going to check to make sure your radicand and index are the same. If they are the same, then all you do is simply add or subtract the outside numbers, so the coefficient values in the front. So let's look at our first example. We have square root of 12 plus square root of 75 minus square root of 3. Now the first thing I would notice on this one is that they all have the same index, but their radicand is different. So what I'm going to do is go through and simplify each of these to see if in their simplified form they have the same radicand. So when I look at square root of 12, if I break down square root of 12, it breaks down into 4 and 3. 4 breaks down into 2 and 2. Remember, when we're doing square roots, you treat the square root like your home, and we're looking for pairs since it's square root. So if there's a pair, that means you get to go out. If there's not a pair, so this 3, that means you stay home. So that one simplifies to 2 rad 3. 75 is going to break down into 25 and 3. 25 breaks down into 5 and 5. So if we look, we have a pair of 5s. So that means those pair of 5s get to come out. This 3, this lonely 3, has to stay home. And then we just rewrite the operation. So there was an addition sign here. There was a subtraction sign here. Rad 3 is already simplified. So then we check. Our indexes are all the same. They're all square roots. And our radicands are all 3s. So that means we can actually go through and add and subtract these. Now this one right here, it does not have a value in front of it, so we're going to put a 1 because 1 times rad 3 is the same as rad 3, so we're going to put that there to mark that value. Then it said on our third step, we're going to take all the coefficient values and we're just going to add or subtract those. So we get 2 plus 5 minus 1. 2 plus 5 is 7. 7 minus 1 is 6. And then the radical, you just treat it like a variable. So it just attaches itself at the end. So your answer is 6 rad 3 for this one. The second example we're going to do involves variables. And I wanted to do one that involved variables so you could see how to break this one down. So again, I check all my indexes are the same, but my radicands are all different. So I'm going to simplify them to see if I can make all my radicands the same. So the first one here, 5 cube root of x squared, I only have 2 x's inside the radical and there's a 3 on the outside, which means there's no way I can simplify this one. So I'm just going to rewrite the first one. The second one here, I have an 8 here and an x squared, so I know the x squared can't simplify, but I'm going to see if I can break down this 8. So I'm going to take that 8 and break it down. It goes into 4 and 2. 4 goes into 2 and 2. Since my index is 3, I'm looking for groups of 3, so that means these 2's can go on the outside. And then that x squared, again, cannot be simplified, so it stays inside. And this addition sign comes down, and then I just drop the first one down as well. So right now I know these first 2 are good because they both have the same index and the same radicand. So I'm just going to check this last one. So x to the 5th, that means I have 5 x's. So I like to write it out so I don't miss anything. So I have 5 x's, and this 3 tells me I'm looking for groups of 3. So I have one group of 3 here. So that means I have one group of x's coming on the outside, and then I have 2 left inside. So those go back inside the radical. Drop down this sign, minus. And then from there, I take all my coefficients, so that's everything in front of the radical, and I add or subtract those. So I get 5 plus 2 minus x. 5 plus 2 is 7. 7 cannot be subtracted from x, so I just put a parenthesis around this. And then again, you treat this part like a variable, so it just attaches. So it's 7 minus x times root 3x squared. So this is my answer. And we're done. We've learned how to add and subtract with radicals. Thank you guys so much for watching my videos. If you want to get better at math, subscribe to my videos here. If you want more information on math, click on my website link here.